All right, everybody. It was good to see everyone earlier today, and let's go over the homework right now. If you were able to join the meeting, you know that we did number one from each of the homeworks, and let's go through number one quickly here. I'm actually just going to read the question from here. It's really sloppy on this sheet. I'm going to go to my answer sheet. A and B manufacture two types of cables having mean breaking strength of 4,000 and 4,500 pounds and standard deviations of 3 and 200 pounds respectively. If 100 cables of brand A and 50 cables of brand B are tested, what is the probability that the mean breaking strength of B will be at least 600 pounds more than A? All right, so let's actually go to the homework worksheet that I made, and then I'll give out to you. All right, so if you missed the meeting, always start with the populations. Here are the populations. A has a breaking strength of 4,000 pounds, and a standard deviation of 300. B has a strength of or a breaking strength of 4,500 pounds, standard deviation of 200. Before we even begin, B is stronger than A. By how much? 500 pounds, 4,500 minus 4,000. That's the key to doing these problems, just taking the difference of the means. So for the sampling distribution, this is really the most important stuff right here. Out of all the things you do, this is what's going to set up the normal curve and solve it for you right there. Samples of A are 100, samples of B are 50. And so let me scroll over that. A is 100, B is 50. The mean difference is just, I didn't write it here, but 4,500 minus 4,000. And standard error, straight from our notes, variance of the first divided by sample size of the first, plus variance of the second divided by sample size of the second, and you get the 41.231. Round off to 3 decimal places always. It says, what's the probability that the breaking strength of B will be at least 600 pounds more than A? But B already lasts 500 pounds more than A. So 500's in the center, 600 is just to the right, and you shade to the right, at least 600 pounds. So I just calculate the z-score, and that's the one thing I don't have on here. The z-score is just 600 minus 500 divided by 41.231, and that's where the 2.43 comes from. And then I look up 2.43 on my z-table, and I get 0.4925. Subtract from 0.5, and I get my answer, 0.0075. So that's number one. Number two, let's go to the homework. What is the probability that the mean breaking strength of B will be at least 450 pounds more than A? But then here's the difference. If 100 cables of both brands are tested, something has changed here. It's not just like putting the number 450 in here by number one and answering it. Now, in this particular case, the standard error changes. Why? Because the sample sizes for A and B are both the same. So your standard error is slightly different. It's 36.056. So you now put 500 in the center, and it's at least 450 pounds more than A. So 450 is to the left. And I plug in, I get my z-score, and the z-score changes now. It's going to be 450 minus 500 divided by the 36.056. And that's how I get my z-score of negative 1.39. I get an area of 0.4177. Add that to 0.5, and I get 0.9177 as my area. There's my answer for number two. You only need to do number two and three. Number three said, what is the probability that the mean breaking strength of B will be less than 450 pounds more than A in problem number one? I know what some of you were thinking here, and check your answers. Two said 450 or more. Number three said less than 450. How many of you, raise your hands right now at home, thought that two and three were just complements of one another? Raise your hands. All right, two and three were not complements of one another. Why? Because number three uses the information from number one. That's why, not the information from number two. So it's the same setup as number one here. So your mean difference is 500. Your standard error is from number one, 41.231. So then even though the answer to number 2 is 450 to the right, and picture-wise, the answer to number 3 is 450 to the left, it's not the same standard error. So you divide by 41.231, and you get a z-score of negative 1.21, and that gives you an answer of, or an area of 0.3869. You subtract from 0.5, and the area of your answer is 0.1131. That is the end of homework number 3. Now, I just want to point something out. I didn't have you do number 4, but just so you know, in number 4, you were taking 2 samples from one population. I mentioned in the lesson, you can take 2 samples from one population with both means and proportions. I know in the lesson we only did it with proportions, but here it's from the means. You're drawing nails from one pile, and so the mean from A and B is the same number, so when you do the mean difference, it's 0. All right, so I just wanted to point that out. You can draw 2 samples from one population, both with means and proportions. Pause, rewind if you need to. I'm going to go to homework 31. Here we go. We did number 1, A and B together. So a vase consists of 50 red and 50 white marbles. 2 sets of 30 marbles each are drawn with replacement from the vase, and their colors are noted. What is the probability that the 2 sets differ by 5 or more red marbles? Let me go to my homework answers for this because it's a bit neater. So it's one population that I wrote here, one population. So population A and B are the same. The proportions of red and white are the same. They're 0.5. There it is right there. I'm just circling it with my hand. All right, standard deviations are 0.5. And so this actually, you know what, this should be right here. Sampling distribution. N sub A and N sub B are both equal to 30. That should actually not be there. It should be up here. So the mean difference is going to be 0.5 minus 0.5. Well, 0.5 minus 0.5 is 0. Standard error is p hat times q hat over the first sample plus p hat times q hat over the second sample, and you get 0.129. And you want to know about getting the difference of 5 or more. 5 or more is wrapped around this. There's 5 out of 30 right there. And here's negative 5 out of 30 right there. Remember, it's a fraction because it's 5 marbles out of 30 and negative 5 marbles out of 30. But if you want to include 5, then you're going to start at 4.5 over 30 and shade to the right. And you're going to start at negative 0.5 over 30 and shade to the left. It's a two-tailed answer because the difference could be 5 or more red marbles in either direction. If you missed the lesson, watch the lesson. You'll see what we're talking about. That gave me z-scores of plus or minus 1.16. And when I look up 1.16, I get an area of 0.3770. I subtract from 0.5. Technically, I get 0.123 right here and 0.123 right here. I add those together, and I get 0.246. That's how I do number 1. A, 1A. 1B is the exact same answer because it doesn't matter whether it's 5 or more red or 5 or more white. There's the same proportion of red and white. Let's go back to the homework here. Part C says more than 2 red marbles. The difference is more than 2 red marbles. That could also be in either direction. So how do you do more than 2? You guessed it. You start at 2.5 over 30 and shade to the right. And you start at negative 2.5 over 30 and shade to the left because you do not want to include 2. There's my computation. I get a z-score of plus or minus 0.65. And that gives me an area of 0.2442. I'm trying to read my own handwriting there. I subtract from 0.5, get 2 areas on the outside, and I add those 2 areas up, and I get 0.5156. All right, 0.65. Now it's getting to me. 0.65. Let's go. Where's 0.65? 0.6, and then 5. It's 0.2422. Sorry, I was having trouble reading my own handwriting. So this is 0.2422. There we go. That's not even any better, but you get what I'm doing right there. Okay, so let's go to now part B. I do believe that part B, I'm sorry, on my end, I keep clicking something that's scrolling it down. Less than 3. Less than 3 means the difference is less than 3 in either direction, but I don't want to include 3, so I am simply starting at 2.5 and shading to the inside. So part C starts at 2.5, shades to the outside. Part D starts at 2.5 and shades to the inside. Yes, C and D are just complements of one another. If you take those two probabilities, they will add up to 1. So that's number 1, everyone. Number 2, let's read it and let's do it. An election. The election returns showed that a certain candidate received 60% of the votes. Find the probability that 2 random samples, each consisting of 200 voters, indicated more than an 8% difference in the proportions that voted for the candidate. More than an 8% difference. It doesn't say that 8% more or more voted for the candidate. It just says an 8% difference. This is going to be a two-tailed answer. More than an 8% difference. So for number 2, the proportions for both samples were 0.6. Therefore, the the mean of the difference is 0.6 minus 0.6, which is 0 once again. You're talking about one voting population here. You're drawing 2 samples from one voting population. Standard error is just 0.6 times 0.4 over 200 from the first sample, plus 0.6 times 0.4 over 200 from the second sample. And you get 0.049. There it is. Okay. It says, show that it shows more than an 8% difference. 8% of what? Well, it's 8% of the 200 voters. So what is 8% of 200? It represents 16 people. So I want to see if there's more than a 16-person difference out of 200. More than a 16-person difference. And I just said it. More than 16 means I don't want to include 16. So we start at 16.5 out of 200 and shade to the right. Start at negative 16.5 and shade to the left. I plug it all in, and there's my z-score formula right there. I actually showed it. 16.5 plus or minus 16.5 over 200 minus the mean difference of 0. That's this 0 right here. Divided by 0.049. Gives me z-score of 1.68. I look up 1.68 on my z-table, and I get 0.0535. I subtract from 0.5. I add them together, and I get my answer of 0.093. That's number 2. Last, but certainly not least, number 3. A and B play a game of heads and tails, each tossing 50 coins. A will win the game if he tosses 4 or more heads than B. Otherwise, B wins the game. Boy, this sounds like fun. Determine A's chances of winning. Now, in this one, it says A only wins the game if he tosses 4 or more heads than B. That's a definite direction. A only wins if he tosses 4 or more heads. It doesn't say the difference is 4 or more. It says A has to toss 4 or more heads than B. All right, so let's get to number 31's answer right here. First off, one population, it's one coin. So the proportion of flipping heads is 0.5. And the mean difference is 0. Standard error is just 0.5 times 0.5. Let me just do with the cursor. 0.5 times 0.5. I just wrote 0.5 squared over 50 because it's 2 samples of 50 plus another 0.5 times 0.5 over 50. And you get a standard error of 0.1. Okay, so it says that A will win. So let me write that right here. Here's the dividing line. A wins the game if he tosses 4 or more heads than B. Otherwise, B wins the game. So there's the dividing line between A winning and B winning. So it says 4 or more heads, 4 or more out of 50. So if you want to include 4, you start at 3.5 over 50 and you shade to the right. You calculate your z-score and you get a z-score of 0.7. You look that up on the z-table and get 0.2580. You subtract from 0.5 and get 0.2420. So there's just under a one quarter chance that A is going to win the game There's almost a three, or there's a greater than a 3/4 chance that B will win the game. Everyone, those are your homework answers. And coming up next, I'll do a review video as well. Hope this helped.